In this lesson, we're going to be talking about virtual memory. Virtual memory is where the operating system needs to be able to store things temporarily because it's run out of physical memory. So you can actually have more programs running than you have the physical memory to be able to store at any given time. And what it does is it stores that information on the hard drive. So in this particular case, let me go to the C drive here. And if we scroll down a little bit, you can see the pagefile.sys that's most of the way down this page. And you can see it's 2.99 gigabytes and was created back in December of 2011, which would have been when the system was actually installed. So we've got the pagefile.sys, and that's where all of the virtual memory, so any memory segments that belong to programs that don't have space in real memory would get stored there. In order to take a look at that and be able to see those chunks of memory, we could open up WinHex, which is a hexadecimal editor or hexadecimal viewer. And what I can do is take a look at the page file here, and you can see there's actually not a lot of information in it, certainly not early on. Although now, as I scroll down, I can see that looks like there's an error most of the way down here, failed to get data for key %x. So it looks like there are some pages from programs that are stored. And the reason it's called a page is because that's how operating systems chunk up memory. So when a program starts up and it requests memory to be allocated for it so it can store its executable code as well as its data, it actually requests it in pages. Unlike blocks on a hard drive, what you get is a page in memory. And so when another program comes along and is actually active and it needs to be able to store information in memory, it requests a bunch of pages, and maybe some pages from the previous program have to get kicked out of real memory and written out to this page file so that it can accommodate this other program that is running more regularly or more currently than the other one. So if you want to see information that's sort of in memory, but not actually in real memory, you could look at this page file, and you just never know what you may be able to find here. And of course, just looking at the page file like this, we have no idea what programs are associated with it. We'd have to go digging through some other utilities to see if we could map what's in the page file to what programs actually own it. And in that sense, it may be a little bit easier under Linux. So there are a few utilities that I could use to take a look at virtual memory. So we've got some virtual memory statistics here, and you can see processes in memory and swap and IO and system and just the different columns that are there. And what we're talking about is pages. So there's swap pages and free pages, and then we've got buffer and cache. So that's statistics around virtual memory. Now, I could also do PMAP, and what PMAP is looking for is a process ID, so it can show a process map for a particular process. So let's get some process ID so that we can take a look at that. And let me see here. So let's take a look at Postgres, which is process ID 2173. And Postgres, if you're not familiar, is a database server. And so let's take a look at the process map for 2173, which is the Postgres process. Now, that doesn't actually have anything interesting in it. So let's take a look at another one here. 16803. Okay, so I actually had to be an administrative user to really look at these processes in the process maps. Otherwise, it didn't show me anything because it's all privileged information. So here's the process map for this particular process. And in this case, it's the secure shell daemon that is allowing me to log in remotely. So you can see the different shared objects or shared libraries that are stored in different memory segments, and you can see their size as well as whether they're flagged for read write or read execute, or in some cases just read. But here's all of the different memory segments for this particular program and what actually they're being allocated for. So I could use this process map to be able to look at all of the memory addresses and all of the things that the memory is being used for, whether they're shared objects or whether, as you see down towards the bottom, it's for the executable itself. And at the very bottom, you can see that there's 132K that's allocated for the stack particularly. Now, I could do memstat, for example, and I could see some memory statistics. And let's just see what I get if I run it with sudo privileges. Now I get a lot more information about what's there. So again, there's a bit of a difference as to whether I run with administrative privileges or whether I run as just a normal user, because some information is privileged, and so I have to be an administrative user in order to be able to look at it. So there's information about the virtual memory for different processes, or more specifically, the memory being used by specific processes. And if you've actually got a swap file configured on your system, we can do the same sort of thing as we did with the page file. And in this case, hexedit/swap file, because I've got a swap file configured on this system and it's just called swap file. And so here's my swap file, and you can see it's primarily empty. There's not really anything in it. And the reason it's all zeros is because when I created it as just a file that's filled with zeros. Here's a little bit of information. So it looks like maybe a page or so of memory that's been stored out here in the middle. But otherwise, there's not really a lot here, which says to me that the real memory that this system has is more than adequate to be able to store the data that is required by the programs that are running. So there's enough memory in this particular system, by the look of it, to be able to store the memory segments, and we don't actually need virtual memory. So I could actually do something like look for strings in swap file and see what I turn up. And it looks like, again, there's just not an awful lot there. And the swap space, too, would have been something written by the operating system. So really, there's nothing being stored in the swap file at the moment. So it looks like the real memory is being used efficiently, and there's no particular reason to swap anything out to disk. But if you did have a heavily loaded system, or one that actually was using swap file, you could do something like strings or use a hex editor on it, just as we did on the Windows system, and be able to see information that's stored there.